Good morning. Welcome everyone to Interface Engineering's 2024 Educational Webinar Series event. Today's presentation has a combined in-person virtual audience, and we'll figure out the sound here in a minute. For those attending in person, welcome to our office. A little housekeeping. There are bathrooms located through the glass doors in the middle of the core. There's a fob also on the front desk to get back in. Please help yourself to the refreshments. Find the sign-in sheet. Should I keep talking? And Eli Solchow, Associate Principal here at Interface Engineering, and they'll do the presentation.
Okay. Thank you, Patty. I appreciate it. And thank you so much for helping to organize our event today. Good morning, everybody. We have a combination virtual and webinar and in-person meeting today. So appreciate people's patience. My name is Roger Frechette. I'm the managing principal here at Interface Engineering, and I'm joined today for this presentation by my partner Kulai Salitra, associate principal with Interface. And before we jump into the presentation content, the educational portion, I want to take just 30 seconds and tell you about Interface Engineering. We are a large national MEP engineering firm with we service market sectors of many different types shown on the screen. We have offices located around the country. We're broadcasting today from our Washington DC office. We work in 45 states across the US and roughly 90 countries internationally. We provide mechanical, electrical, plumbing, fire protection services, but also daylighting, energy modeling, building technologies, and commissioning services. So that's it for the sales pitch. We'll jump right into the content. So today's discussion is called Inside Appendix Z, Net Zero Energy Compliance. And as Patty said, this is an AIA certified presentation, and the number is on the screen. So why do we need to know any of this? And just real quickly, as of right now, the current energy code in Washington, D.C. is the 2017 District of Columbia Energy Conservation Code, which was finalized and went into effect in 2020. And it is based on ASHRAE 90.1 2013 with D.C. amendments. And within this code, there are a number of different alternate compliance paths that you can choose from for district-owned, district-funded, and commercial buildings throughout the district. And I've listed here the compliance paths: ILFI Living Building Challenge, PHIUS certification, PHI certification, LEED certification, and Appendix Z. I think historically, most people have chosen the LEED compliance pathway. It seems to be the one with the fewest number of hurdles, and again, it's based on the ASHRAE 90.1 2013 calculation. So, however, since March 31st of 2023, there was a change, and the Green Government Buildings Act of 2022 requires that new construction and substantial rehabilitation projects in the district apply with, or I should say, comply with Appendix Z for district-owned and district-funded buildings, buildings using district dollars. So Appendix Z has been part of the current energy code as an alternate compliance path since 2021. However, because it has been voluntary, I don't think there have been many projects that have elected voluntarily to use Appendix Z. But again, for right now, if you are designing a government building for DC or a government-funded building, you must comply with Appendix Z. And there's a big change coming. Based on the current law, the Clean Energy DC Building Code Amendment Act of 2022 will require that Appendix Z must be used for all new building permit applications in the district after December 31st of 2026. So if you're not familiar with Appendix Z right now, it's likely you're going to become very familiar with it in the very near future. So what is Appendix Z? It is a net zero energy building and electrification code for the District of Columbia that regulates not only design, but also construction and operation of buildings to reduce energy use, eliminate combustion of fossil fuels for heating and cooling the building, and achieving net zero energy performance. And it also provides some definitions for the term net zero energy for commercial buildings and multifamily buildings. So Appendix Z is broken down into 5 sections, Z1 through Z5. Z1, there's really no action items. It really expresses the intent of the code. But Z2 sets forth the minimum performance requirements. Z3 discusses the requirements for renewable energy. Z4 for metering, monitoring, and metering, monitoring, and reporting. And then Z5 for post-occupancy performance verification. So the intent of Appendix Z sets forward thresholds to achieve net zero energy and electrification, which includes reducing energy demand. It includes incorporating renewable energy, and it includes really the need and methodology and governance of the energy modeling for compliance. They are very specific, not only what models need to be done, but who needs to do them. So within the minimum performance requirements, again, this section is further broken down into 6 elements that need to be complied with. One is building energy use intensity. The second is building thermal energy performance. One is how to measure the energy distribution when you have multiple buildings on the site. The fourth is the professional responsibility of the energy model itself. Section 5 talks about building commissioning, and then 6 about air tightness testing. So drilling down into the building energy use intensity, the performance index known as the ZEPI index, and the ZEPI index is expressed by the EUIP divided by the EUI times 50.4. And so the EUIP is the energy use intensity for your proposed design, and the EUI is a baseline calculation based on source EUI. This is a lot different than what has been used in the past. Generally, when projects have calculated the baseline energy use intensity, it's been based on just the site, but in this calculation, it takes into account not only the site, but the efficiency of the source. So the ZEPI number is the EUIP divided by the EUI times 50.4, a dimensionless number. and that number must be less than or equal to 30 to be in compliance. So the calculation parameters, calculations must be done in accordance with Appendix G, ASHRAE 90.1 2016. Again, the current code, if you were to follow, say, a lead compliance path, is 2013. The appendix, the ASHRAE 2016 version is quite a bit different than 2013. The methodology used to determine the EUI is very different, and overall, the 2016 code is more stringent. So the calculations must be done in accordance with an approved modeling guidelines that are published by the DC Department of Administrative Bulletins. I should have said this presentation will be available on our website for any to download. So I've included some links here to be able to access these bulletins and these guidelines. So modeling inputs must be in accordance with the ComNet Rules and Procedures Manual. I've provided that link. So for calculating the annual energy use indices, electrical energy shall be converted from kWh to kBTU units, 1,000 British thermal units, measured at the utility meter or metered point of delivery. This value shall be multiplied by the dimensionless conversion factor of 3.28 site source factor based on the eGrid subregion 2010 RFC East as stated in the table Z2 1.2.2 of Appendix Z. So what is this 3.28? Again, when you're looking at the performance of not the site, but also taking into account the source, the U.S. Electric grid is not uniformly efficient across the country. Various segments of the country's grid have different levels of performance. So this is something that is closely tracked and measured by the U.S. EPA, and there are in total 15 different regions throughout the U.S., and each one of them has different calculations to determine how efficient they are, the total carbon emissions, the total, total kBTU per generation. So information is extracted. So for the Washington, D.C. area, we are focused on the eGrid subregion RFC East and the data associated with that area. Going even further into section Z2 for building thermal energy performance, not only does the overall project need to demonstrate a level of efficiency based on that ZEPI number, but in addition to that, you also need to demonstrate that you are under a maximum annual heating demand of 4.2 kBTUs per square foot per year, and under a maximum annual cooling demand of 6.4 kBTUs per square foot per year. Again, based on ICFA, the interior conditioned floor area, is how the methodology for determining what the square footage is. So those are two critical numbers, 4.2 for heating and 6.4 for cooling. When you have multiple buildings on one site, each building must comply with sections 2.2.1 and 2.2.2 within Appendix Z, or the combined demands of the buildings on the site shall comply. So each building sites employing district energy systems, the energy shall be designed to each building proportionally based on the gross area. So if you had an on-site heating plant, you would distribute that energy or that demand, I should say, across each of the buildings based on the proportion area. So for building sites employing renewable and/or waste energy systems, the energy shall be assigned to each building proportionally based on gross area. The exception is where it can be shown that the use of the building on the site is associated with a specific building. So another requirement of Appendix Z is that a registered design professional and responsible charge of the building energy simulation. So the owner shall engage the services of a registered design professional in responsible charge of energy simulation. The registered design professional shall be named on the permit application, and the design professional shall be certified by an approved accredited entity as determined by the code official. And the owner will be required to notify the code official in writing whenever that registered design professional is charged or unable to continue to perform his or her duties. So through this Appendix Z, they're really elevating the significance of the energy model and the qualifications of the individual or individuals that are producing these energy models, and also ensuring that these individuals are carrying through the entire project. And if not, it needs to be communicated to the district. ZEPI or Z 2.5, building commissioning. All systems shall be commissioned in accordance with the Energy Conservation Code commercial provisions. Building commissioning must be performed for building envelope, HVAC systems, both active and passive, lighting and daylighting, domestic hot water systems, and renewable energy systems. So the commissioning is a requirement. Something that is new to Appendix Z, air tightness testing is also a requirement. So whole building pressurization testing shall be conducted in accordance with section 11.3.1.2.4a within the Energy Conservation Code commercial provisions. So the owner shall verify that the air tightness specified in the final approved predictive energy model is achieved in the field by providing the code official with a copy of the test results before the final certificate of occupancy is issued. So what this means is assumptions are made in the energy modeling regarding how tight the building is. This air tightness testing must verify that you are achieving at least that level of tightness. And if those two things don't match up, it is possible that you may not be issued your certificate of occupancy. I'm going to turn it over to my colleague Kulai to take us through Z3.
Okay, so Z3 is dealing with renewable energy, and the property it's looking having the building and the site around the building for the total power generation. So these formulas are formulas that we produce it, not you are not going to find it in Appendix Z, but PG is power generation, and the power generation is made of power generation on site plus power generation off site. The power generation that you are going to calculate needs to demonstrate that is bigger or equal than energy use intensity proposed or for the project. Sorry. Okay. The second requirement on the Z3, it's referring to the on-site combustion. The on-site combustion of fossil fuels will not be permitted on the provision of thermal energy to the building, except as specified by the code official. In other words, natural gas generation for thermal is not used, should not be used anymore, and the electrification should be provided for the building itself. Sorry. That's one.
That's just slow.
Sorry. So the number 3 requirement, it's the acceptable sources of the energy, renewable energy. So as you can see, the acceptable source of energy, renewable energy, are only these 4: photovoltaic panels, solar thermal systems, wind turbines, and biogas. We don't see the geothermal here as a recognizable renewable energy, but the geothermal can be used in your mechanical system to make the system more efficient and drive the UI proposed or the UI of the project to go down, and that helps with the ZEPI number. And number two, no other sources on an on-site renewable energy is acceptable unless approved by the code official, which makes me to say that other sources could be used on off-site if you are going to decide to buy energy, renewable energy from outside the site. The renewable energy on site. How the renewable or the quantity of renewable energy on site is determined? So the on-site renewable energy shall be generated whenever feasible, and feasible, it's quite loose. I don't know. It's very it could be interpreted, but on number 2 and number 3, they are specifically asking for specific numbers. So a minimum of 5% of the total building energy consumption, UIP, shall first be met by an acceptable source of renewable energy installed on the building roof or site. So they are very specific, 5%. Now, for project generating on-site renewable energy through solar photovoltaic system, a minimum of 25% of the total site area, including building footprint, shall be allocated. It doesn't say that you have to put 25%. As long as the UIP is met, I think that they are okay with that. The exception here is that where there is no adequate solar access to determined by Chapter 13 of Energy Conservation Code commercial provision, you don't have to meet this requirements. For the renewable energy offsite, so we determined that on-site is not possible to provide enough renewable energy, then Appendix Z allows you to go and purchase the renewable energy from off-site. So energy must be procured from a qualified electricity supplier, providing energy from Tier 1 renewable energy sources, meeting the minimum percentage of DC renewable portfolio standard. So DC is providing the renewable energy portfolio standards every year, and in that they are indicating a very long list of actually suppliers, Tier 1 renewable energy. What means Tier 1? Tier 1 means that the suppliers will provide renewable energy by PV, thermal solar, biogas, and wind, and also hydroelectric. But the hydroelectric needs to be less than 30 megawatts. So I don't know many hydroelectric plants around our area that are capable to provide less than 30 megawatts. The following methods of procurement are acceptable. Power purchase agreement, which is the most used in the area, for a minimum of 5 years from solar or wind facilities located in district DMV area, connection to a renewable energy microgrid, and connection to a low carbon neighborhood thermal energy system. I don't know too many energy microgrids or low carbon neighborhood thermal energy system in our area yet. So the majority of the projects that tend to go after net zero certification, they generate their renewable from PV. Wind is not prevalent in our area, and I don't see many projects with incorporating the wind generation.
Moving on to the requirements of Z4, energy metering, monitoring, and reporting. So these requirements apply to all projects using Appendix Z to ensure that the buildings are constructed or altered with the capability of measuring, monitoring, and reporting on their energy use, production, and reclamation. So this includes the design of energy distribution systems, to allow for the isolation of load types, the installation of meters, devices, and data acquisition systems, and the installation of energy displays and other reporting mechanisms. So not only do we need to provide metering for the systems, but under Appendix Z, they're looking to be able to isolate the specific load types.
Can I say something? The submetering system that they are looking, it's usually by separating the loads on receptacle, HVAC, lighting, equipment, and that can be done easily by creating your distribution as such that it's separated on that type of loads.
And so all forms of energy delivered to the building site or produced by the building site or in the building shall be metered and all energy load types measured. So within the ventilation system, part of the code is they're looking to understand the ventilation rates into the individual buildings and looking to have the ability to not only measure how much ventilation is coming into the building, but to maintain historical data regarding these ventilation rates. So within the building's mechanical systems, we must have devices capable of measuring and reporting that flow, such as airflow measuring stations within the associated with a DOS unit. And the building would be an example. You want to talk about grid integration?
Sure. In places where equipment constraints in the distribution network, net metering, it's impossible to be provided because the utility doesn't accept it for some reason. The on-site storage option shall be considered. Something that I want to underline is that this is the only location in the Appendix Z that they talk about the on-site storage. I'm not so sure how they are looking if you are providing on-site storage, other than when the net metering, it's impossible on site, they are going to react. These systems are expensive, they are very difficult to control, and they require a lot of specialty equipment to be monitored.
I think it's one area within Appendix Z where there's a little bit of leeway. It's essentially saying you must net meter the building, and if for whatever reason you cannot net meter the building, that you should consider on-site storage options. Doesn't say you must implement on-site storage options. So Z5, post-occupancy measuring and reporting. So this is post-design, post-construction, when the building is now operational. There is a requirement for the owners to annually benchmark and report on their energy and water performance through the Energy Star Portfolio Manager tool. And this includes the renewable energy generation and green power usage pursuant to DCMR 20-3513. And then the owners shall also create an Energy Star Portfolio Manager and property record on the U.S. Environmental Protection Agency's website and share the property with the District of Columbia's Department of Energy and the Environment. The code official is authorized to require proof of this compliance. And I provided at the bottom a link to the DCMR rule. And performance verification. So within 24 months of occupancy, the owner shall submit documentation demonstrating 12 months of continuous operation with no less than 90% occupancy, where the energy consumed by the building and the building site are equal to or less than the renewable energy associated with the building and the site. So essentially saying you are producing more energy than you are consuming, which means by their definition, you are operating at net zero energy. So from a timing perspective, what they're really saying is when the building opens, you really have 12 months. You have 1 year to work out the kinks and to get all the systems working properly and the measurements in line, the calibration done. And then after 12 months, you would then start the detailed measuring and show another 12 continuous months of operation under that net zero condition with at least 90% of the building occupied. And then at the end of that second year, submit that performance record for verification. So the owner may submit documentation demonstrating abnormal weather or occupancy conditions during the compliance period, if they believe that there is valid proof of these abnormal conditions that have led to a condition where maybe the energy use is of the building is greater than the energy performed. Perhaps an extended length of cloudy, rainy weather may fall into that category that is beyond the weather file within ASHRAE Appendix G. So that's a summary of the Appendix Z. And I guess the best way to summarize it is moving forward, but we will need to demonstrate that buildings can operate at net zero energy, that their energy consumption will be reduced to fairly low numbers for heating and cooling and overall energy consumption, and that the buildings provide renewable energy either on site or through a power purchase agreement or some combination of the both, and that the amount of power being generated is greater than the amount of energy consumed. That's one big mandate of this Appendix Z. The second is they're looking for these buildings to be fully electrified. They are leaving the door open to be able to use fossil fuels for emergency power generation, for example, but anything that has to do with the thermal energy of the building, heating the building, cooling the building, heating hot water, all of these things must be done with means other than the use of combustion of fossil fuels. So it's a pretty big step and a pretty big change from what we've seen in the district, up until now. So as we said at the beginning of the presentation, this is something that is coming for commercial buildings, but it's something that is here for government-owned buildings. So we wanted to provide one case study of a DC-owned building where Appendix Z is required. So this case study is of the Neville Thomas Elementary School, which is located in Anacostia and Northeast Washington, DC. And it is a building that is renovation and addition for K through 12 school. So here's a diagram of the school. This area in blue here is a portion of the current elementary school, which is being maintained, is going to be renovated to meet the Appendix Z criteria. The rest of the existing school will be demolished. And what is in red here is the new portion of the school, which will be added on. But the entire project must demonstrate compliance with Appendix Z. So from a design standpoint, one of the first things we need to do is to build a proper energy model that is reflective of the design that has been proposed, so that we could test various strategies, measures, and technologies. We have gone through many iterations now of energy modeling to show the difference between the baseline energy consumption and the energy consumption with the proposed design. So the darker blue represents the baseline, the minimally code compliant condition within ASHRAE 90.1, and the lighter blue represents the anticipated energy consumption associated with our proposed design. And as you can see, looking at the top pie chart versus the bottom, we were able to show quite a considerable reduction in energy use over the course of a typical year. Some of the technologies, strategies that have allowed us to reduce energy by that amount have to do with the incorporation of a full-scale geothermal system connected to water source heat pumps. That system has given us a much smaller energy footprint, but also our lighting systems and lighting control systems have also, allowed us to save quite a bit of energy compared to the baseline. One thing you'll notice is that pumping energy actually increases with the proposed design, and this is because of the introduction of the geothermal system and the pumping through that system. So when we compare the baseline to the proposed for heating, cooling, lights, equipment, fans, pumps, hot water heating, and combine those together, we see that we end up with a ZEPI score of 28.3. Again, the requirement is your ZEPI score must be below 30. So this project, this energy model suggests that the building is in compliance with respect to the ZEPI. We then need to look at the building thermal cooling demand, and our calculation shows that for the proposed design, we've been able to achieve a mark of 4.96 kBTUs per square foot per year. Again, the maximum allowed is 6.4. We're under that number, so we passed the test with respect to building thermal cooling. When we look at building thermal heating, our model demonstrates that we can achieve 1.42 kBTU per square foot per year. Again, the criteria is that we must be less than 4.2. So once again, on annual heating, we are in compliance. And then when we look at on-site solar energy, we've modeled this through the course of the year. Our calculations show that we should, in a typical year, be able to produce 648,590 kilowatt hours of power production. So then when we look at our proposed design on the right, our EUI of the proposed building translates to 370,000 plus kBTUs, and our power generation is 648,590. So our power generated is well above the expected energy consumption. So as long as, again, that PG is greater than or equal to EUIP, then we pass the test with respect to the Z3 renewable energy. So this is not in Appendix Z. This is a checklist that we have created for ourselves. But again, we suggest others please borrow it if you'd like. But this first slide shows all the design-related Appendix Z requirements. So ZEPI less than 30, where we passed. Annual heating demand, we passed. Annual cooling. Is the registered design professional responsible for the model? Yes. We've confirmed that our design includes all the required metering to meter all the energy load types. We've confirmed that the design does not include the combustion of any fossil fuel for thermal energy. We've confirmed that the model performance of on-site and off-site renewables exceed the EUIP. And for on-site only PV, we've confirmed that 25% of the site area has been allocated for photovoltaics. And we've confirmed that the measuring and data collection capability for central ventilation systems has been included. We are showing those airflow monitoring stations in our design. And then if net metering is not possible, confirm energy storage. Well, again, in our case, net metering is possible. So we have passed that criteria. We've also included a second checklist, and this is for the future phases for construction and for operation. So these have not passed yet, the reason being as we are just now reaching 100% complete design. The project has not gone into construction yet, but before the end of construction, we will need to verify that the air tightness testing has been completed and submitted, and that it is within the bandwidth of what is shown in the energy model. The building commissioning process will need to be completed and submitted. and that, again, if offsite renewables are required, that contract has been procured. In our case, that is not applicable because 100% of the PV generation is being handled on site. And then beyond construction, the last two steps operationally is conformance, confirming the performance of verification within 24 months of operation, and confirming that the annual Energy Star benchmarking has been accomplished. So we have achieved what we need to in design to be able to be permitted under Appendix Z, but there's still work to be done ultimately before a certificate of occupancy can be given. So we, within the presentation, I've provided a link here so that you can download your very own copy of the Energy Conservation Code Appendix Z for review. And I think with that, that wraps up the formal presentation, and I'll turn it back to Patty for Q&A.
Yeah, and if questions, just
Okay, let's start with some questions in the room.
That's the site.
What was it? What was the value?
The UI for the.
Yeah, what was the number? Yeah, okay. So the question was for the Neville School, what the EUIP ended up being within the calculation, and the answer is 45. Yeah. Okay. Okay. So the follow-on question is, had we not used the source calculation for EUI, if we use the site EUI calculation, that equivalent number would have been 15? Yeah. Just under 15. Okay. Very good. Thank you. All right. Any other questions from the in-person group?
You talked about data storage for ventilation. Do they say for how long?
No.
I feel like they don't.
Yeah, they don't. They don't within the Appendix Z document. The question is for data storage, for airflow, or for ventilation to the buildings. They discuss the need to collect historical data, but they do not stipulate the length of time that data must be collected and stored. So, again, I would say Appendix Z is still, it may not necessarily be a brand new document, but I think it's being used for the first time in the last year and a half. I guess I'm guessing that there will be revisions of that document that'll come up that'll provide some clarity on some of those kind of items. But for right now, no, they do not stipulate.
A follow-up to Kevin's question. For the reporting, and then maybe I just missed it, do they specify how you are to report all of the information that you are gathering? I know typically it's been done through the portfolio manager, but I don't believe the portfolio manager has a section for like ventilation and some of these other things. Is that?
So they do stipulate basically approved the portfolio manager, but it is those energy, water, ventilation. I think to Roger's point, they haven't really defined how they want to see that reporting. I think it's more a matter of being able to go into the system and confirm that you are getting the appropriate ventilation energy.
Yeah. So for those online, the question is, specifically how do you report some of this information to DC to be able to demonstrate compliance? I think in the case of the design, that information needs to be incorporated into the permit application itself. And for example, for our school project, we created a chart that showed the requirements and showed the values that we were able to achieve and show that we were passing. When we get into the operational piece of it, within portfolio manager gives you the opportunity to put some of this information that we're talking to, but not necessarily all of it. So it does lead to the question, in what form does some of this information need to be submitted to the District of Columbia? And I think for right now, the question is, or at least I don't know. The district may have an answer, but it's not clear within the Appendix Z document specifically how that is to be done.
DC doesn't quite, you know, the green sheet.
Yeah. The Google Doc.
The energy conservation code is 2013. So values are not the same. So what we have gleaned, or at least correspondence with the DC green reviewers, has been that green worksheet is not required. You're submitting the energy model. So that's a new sort of a wrinkle, and it's not broadly provided on their website as part of that application process.
So I would say not a question, but a comment that even on the permitting side, there still is a lack of definition of formatting of how the information should be assembled and included within the permit application. Okay. Any other questions? I thought, yes, sir.
I guess for me, why is the requirement for energy for heating stricter? Heating in this area is the bigger differential.
The question is, why is the requirement for heating more stringent than for cooling? I don't know that this is my guess. I don't know the real answer, but I think the reality is that they're not looking at those as equals. I think they're saying they understand typically what buildings use for heating in this region and typically what they use for cooling. The EUI for cooling will always be higher than heating for most building types within the district. I think they're looking at taking those two values, one that's always higher than the other, and they're reducing both of those numbers to. Sorry?
So the thermal is the heating and cooling load that the mechanical systems have to overcome. So it's your building envelope, it's your lighting, it's your people, it's your equipment. In this area, we're cooling year-round, right? Our internal loads can be that we're cooling year-round. So that's why that number's higher. It's because it's accounting for everything in the mechanical system.
Yeah, so the comment was again that, cooling will likely always be higher than heating in this region because the cooling, many of our buildings, we are in cooling mode year round, but we will only be in heating mode for select months of the year. The intent really is to take the normal amount of consumption in buildings for heating and cooling and reduce both of those values. I think to me, what is really unique about Appendix Z is we did not get into that level of granularity in requirements in the past. We simply looked at the building and its total energy consumption through the course of 1 year and said, you need to demonstrate performance to have that number achieve, a certain level. Here, they're saying you still need to do that, but in addition to that, they've now drilled down to look at specific heating energy and cooling energy and say you also need to make sure that those numbers are down within specific limits. So I think that's really what's kind of really new about Appendix Z with respect to the modeling. Any other questions in the room?
Just to add on to that. So the interesting thing that DC has been doing, and this sort of came in with the whole building energy performance standard. So a lot of these values that they're using, like thou shalt meet some number, to your point, that is based on their analysis of building stock throughout DC. Buildings have been reporting their energy usage via portfolio management. But DC now reserves the right to change those numbers, right? So the minimum heating and cooling performance values, likely as the codes develop cycle by cycle, those numbers will likely get smaller. because that's the intent, is they want you to be more efficient than you were the last time. So my understanding from conversations with the folks in DC is that as part of this process and the building energy performance standard process, which they have come out and said that those values will change every cycle. The idea is that they take that information that they glean during that cycle and then they put it back into the codes to make sure that building performance is being progressive, right? So it's not just kind of stuck on one number forever. And then 10 years later, that number is no longer relevant, or they have to fudge it like, no, you need to be X times better than that number. I believe that the intent is to sort of augment those values over time.
Yeah. Okay. So for those on the online, the discussion really is about the likely intent of the district to be able to start with these particular values that have been offered as maximums for heating and cooling, and then to evaluate the energy models that are that are being submitted for the various projects, and then based on what architects and engineers are able to achieve, potentially augment those numbers over time to make sure that we are raising the bar at appropriate levels without over stressing what is possible or plausible within the designs. Okay. Anything, Patty, from?
No, there's no.
Okay. Okay. So no questions yet from those connected virtually. Anything else from the room? Yep.
Question about electrification. Where do they account for, is it because of when they say source, that is it the electricity generated from the fossil fuel, gas or coal? What does that mean? Does it involve calculations or equation, or does it mean nothing? And then I've heard different opinions about whether there is enough electricity to actually serve this city in its code and the distribution system of it. So what are your thoughts about that?
Okay, could you repeat the first part?
The first part was, if the electricity is generated by fossil fuels, does that make a difference in these calculations?
Okay. All right. So two-part question. One is the question of, if the it's about electrification. So the code is demanding electrification of buildings for thermal energy. So part one of the question is, well, what if that electricity that is being provided by the burning of fossil fuels to deliver that power? Is it really a benefit? And then secondly is a question about capacity, and that is, if every building were suddenly to be fully electrified, does the city's grid have the capacity to handle that additional load? So starting with the first one, again, I think it comes down to intent. Certainly, much of the existing electric utility grid is being sort of satisfied through the burning of fossil fuels, whether that be natural gas, number two fuel oil, diesel, various coal in some cases, so different combinations. So there is a penalty, if you will, of carbon emissions associated, with the existing grid. I think the city is looking at the trend, though, and the trend in the United States is that year by year, the existing electric grid is becoming greener. There are, more and more of the total capacity of the grid is being comprised of, power from wind farms and from solar farms, and their own equipment, I think, is becoming a bit more efficient, some hydroelectric power. So I think the intent here is, if we go to the electric grid, and if the electric grid continues on this trend, then it will be much more efficient in terms of its carbon footprint than us trying to generate our own, energy on site through fossil fuels. The second piece of it, does the city have the capacity? I don't know if I have an answer for that. I'm not sure. I'm assuming that there has to have been some conversation between the district and and say Pepco about, hey, are you ready for this? But I don't know the answer to that question.
I can add a little bit. So if you look at the the material that we discussed today, they specifically say that the energy that you have to provide on site, it's coming from renewable energy. So the outside energy doesn't play any role. But if you go and purchase energy from offsite, you have to purchase energy from providers that are on the list of the tier 1. And that tier 1 specifically said that the sources of energy that they have and they are producing, it's photovoltaic, wind, biogas, and thermal storage. So although, you know, Pepco and every other utility have in their portfolios, they have that possibility. So when they sell energy, they have to sell energy to you based from their portfolio, not from nuclear, coal, or natural gas. Is that segregation happening? I don't know. When it comes to number 2, does the utility grid it's able to sustain the growth? I think it's a big concern. The concern is not only the production, but I think it's the infrastructure. The infrastructure in the United States is so old that it's failing left and right. When they've been designed, the major infrastructure that we're talking about, medium voltage and super high voltage, it was designed 50, 60. Utilities are not maintaining very well those infrastructure, and there are possibilities of major failures. So I think that the District of Columbia and other areas in the United States, they are looking to have energy production on site as much as possible, just to take out from the equation or from the transmission lines as much power as possible and still maintain the distribution, you know, live. But there are major concerns. It's not only here, throughout the United States.
Yeah, I'm going to add one more thought onto that, and that is that when we look at the breakdown of buildings and how they have been designed in the past, you know, the bigger loads in the building tend to be on the cooling side, and with lights and with equipment, say in an office building, office equipment, those have always been electric powered and will continue to be so. So the shift really is on how we heat buildings and how we heat our hot water. I mean, I think that's really the big shift here. Those are the numbers that are moving from what has been predominantly natural gas fired in the past, to electric within the city. So.
But you bring up an interesting comment, because the baseline systems for ASHRAE Appendix G, heating is fossil fuel. It's gas-fired hot water, it's gas-fired boilers, and domestic hot water is fossil fuel. And when you go to source factors, on-site fossil fuel, the source factor, we saw the 3.48 for the electric going to the source, you know, the site to source factor. For gas, it's like 1.1. So almost electrifying it when you're going to the source numbers to do the ZEPI, there is a penalty inherently in doing that. So that's why what they don't want you to do is just electric resistance heat. Use a heat pump system, right? So you're getting simultaneous. It's not all electric. You're sharing sort of that heating and cooling. So that's what they're driving the systems.
Yeah. So trying to paraphrase the comment just made, and that is that because of how the calculation needs to be done within ASHRAE 90.1 Appendix G, the baseline is actually a gas-fired baseline. So if you were to simply replace that with electric resistant heating for hot water and building heating, you'd be paying a penalty in the calculation. So to be able to make up for that, the systems that we are seeing are not electric resistant boilers, but instead we're seeing a big rise in the use of electric air to water heat pumps for the purpose of generating heat for building heating and building hot water. And that the efficiencies of those systems are better, so it helps to offset some of the penalty that you would otherwise be paying.
Another comment I want to make on the electrification side for existing buildings, because DC encourage the government buildings and the other buildings to be electrified. You have to pay attention to the capacity of the building. It's not only that you have to be aware or worry about the distribution that is coming from outside, but the distribution that is coming inside. We have done projects where we had to add almost 50% capacity, extra capacity in the distribution system to be able to work with the air water source heat pumps, or air to air, air to water source heat pumps. They are big loads. Not only that they are big physically, but they are big as energy hogs. So that they are taking a lot of it. And then there is, because the buildings are the distribution of the building are relatively old, 30, 40 years, those distributions are finicky. So the owner needs to spend quite a bit of money to bring the buildings to the actual code standards. So it's going to be an interesting development in the following years to see how the market reacts to it. Because I think probably the government may give some subsidies or might not, I don't know. But it's good to keep in mind that it's not free.
Yeah. All right, everybody, I'm going to wrap things up. Really appreciate the great questions and the great conversation and comments. I think that, again, this Appendix Z is going to be a big part of our lives, within starting now and certainly within the next year and a half or so. It'll be a bit of a ride. I'm sure there'll be more information, more changes to come. But I'm going to turn it right now back over to Patricia.